Hello and welcome to this class, the application of improper integral, Torricelli's trumpet. In this lesson, we're going to talking about an interesting problem in mathematics called Torricelli's trumpet, also known as Gibberi's horn. It is a particular geometric figure that has infinite surface area but finite volume. The name refers to Christian tradition identifying the archangel Gabriel as the angel who blows the horn to announce Judgment Day. The properties of this figure were first studied by Italian physicist and mathematician Torricelli in the 17th century. How to create this figure? Let the curve y is equal to 1 over x on 1 to infinity be revolved about the x-axis, thereby generating a surface called Gibberi's horn. This is a picture which I draw a graph of the function y is equal to 1 over x on the interval of 1 to infinity. Now let's revolve it. Then we can generate this object. So the object made like this. This is a trumpet which is not a real Torricelli's trumpet with infinite length. But we may get some ideas of Torricelli's trumpet from it. We claim that the volume of the Torricelli's trumpet is finite, but the surface area of the trumpet is infinite. To put this result in practical terms, they seem to say that the trumpet can be filled with finite amount of paint. Yet there is not enough to paint its inside surface. Before we try to unravel this paradox, let us establish 1 and 2. We use results of volume and surface area. First, to find the volume, we know it's a solid of revolution and slice generates a disk. The disk is a thin cone-shaped object. Recall that the volume of a circular cylinder is pi r squared times h. Here r is y, that is 1 over x. Then we can express the volume of the disk. Therefore, the volume is an improper integral from 1 to infinity. That is 1 to infinity pi 1 over x squared dx. So the volume of this horn is finite and it's pi. Second, to find the surface area. To find the surface area, the circumference of the disk is 2 pi y, and the side area of this disk is 2 pi y times ds. Next, we find ds. And dx is 1 plus dy over dx squared dx. So the surface area is improper integral from 1 to infinity of 2 pi y ds. And we plug in y and ds, we will get this definite integral. And because it's an improper integral, so we'll first find the definite integral of 1 to b and let b goes to infinity. But it's hard to solve it. Now let's simplify it. So the integrand is square root of x to the fourth plus 1 over x cubed. And you see the square root of x to the fourth plus 1 is greater than square root of x to the fourth. So this part is greater than 1 over x. And 1 over x is very easy to integrate. Thus, we get this surface is greater than 1 to b, 1 over x dx. And we let b goes to infinity. We can get that because the improper integral of 1 over x goes to infinity, so the surface goes to infinity. Is something wrong with our mathematics? No. Imagine the horn be slight along the side, opened up and laid flat. Given a finite amount of paint, we could not possibly paint this surface with a paint coat of uniform thickness. However, we could do it if we allow the paint coat to get thinner and thinner as we move further and further from the horn's flat end. And of course, this is exactly what happens when we fill the unslate horn with pi cubic unit of paint. Imaginary paint can be spread arbitrary thickness. Torricelli's trumpet, or gibberish horn, is a staple of calculus textbook. It may also be the perfect imaginary musical instrument. That is, object constituted by its precise mathematical description, yet impossible, due to its infinite length, to realize in material form. The geometrical object was discovered by Galileo's student and successor Torricelli, also famous for the invention of the barometer. Using Cavaleri's theory of invisibles, Torricelli demonstrated that the object, though infinite in length, has finite volume. Because it contradicted the intuition that an object of infinite length would have infinite volume, the demonstration immediately captured the attention of geometers and philosophers and prompted a revaluation of the relationship between mathematical and physical reality. Whereas the Pythagorean tradition maintained that geometrical principles govern the material world, that is, everything is number. The counterintuitive behavior of infinity suggests a cleft between the ideal truth of mathematics and the realities of physical space. Torricelli called his geometrical object as this long name. That means acute hyperbolic solid. The names Torricelli's trumpet and gibberish horn seem to have come into use much later, perhaps with the modern calculus textbook, with its mind-bending combination of infinite and finite dimensions. Torricelli's trumpet describes an interpenetration of the idea and the material and invites us to imagine a music at the intersection of the impossible and the real. All right, that's all for this section. Thank you.